Now we're going to continue on looking at our analysis of the phased array sweep using the label indications. So previously we showed how we can gather information about the relative locations of indications using the indication separation and group indications, and how to gather features about the individual indications using the internal data loop. For instance, we used the indication orientation 2D to figure out the angles that the indications were at. Okay, so next we want to, and so what I've done here is I've put those two workflows together in this workspace. So we have our features from the internal tree and the features from the group indications. And let's look at the data we've gathered in the indications, label indications in the table in the label indications. Okay, so first thing to notice is, I'll just look at this book value. So the indication table has 4 books in it, which have different values in it, and we'll just look at the first two. The first one is raw values, and that means pixels for positions and digitization levels for amplitudes. In raw position, we've done the conversion to distances for the position values, and converted amplitudes for peak values, say percentage or voltage. And there's a couple of other there. Converted positions would be if you had a time to distance. Raw positions would be microseconds. Converted would be millimeters. Okay, so we have these values in here in the tables in the various books, and we just want to start by being aware of that. And we also remember that we have the values of these 7 columns that we created, the angle to the group Z count. Okay, so the main thing you might notice with this is it's not very user-friendly, so we'll start and make it to try to make it more intelligible. And to do that, we will take an indications data node and drop it on there. We'll drop the indications node on the editor, and I'm just going to run a couple of tasks. Init with standard columns and init internal data columns. Okay, so you can see our internal data columns, and then it's done some sensible values for the positions of the indications and the peak, and some labeling as to the indication index and the source output it came from. And we just double click and look at that, and you can see already this is a lot more intelligible table. Okay, so I'm going to go over how this syntax works now, and it works as follows. So if you look up to the label node above it, there are basically 3 types of data that are available. There are the properties of the node and the outputs. So properties is the first type. There's a table here, that's the second type. And then there is the actual data in there, so the value in the data array. Okay, so 2 types of data, and then 2 places where we have data, the node itself and then the outputs. And so if you understand that, then you can understand this syntax. So we'll start with this one. So source output means an output, the blue portion here, and it's the name. So in this case, this isn't a particularly interesting number, but you can cluster across multiple outputs. So in that case, that would be a helpful value. The rest of the stuff we're getting to the table, from the table. And so source node is the node, and the cast as a table means look at the table portion of it. And then book equals tells us that which book to look in. If there's no indication of book, it would just be the first book, the book 0. And you can also put page here, comma, page equals something. Okay, so I think that covers the meaning of all these. We don't have an example of getting at data. We'll do that soon. But we need to do equations too. So I'm just going to grab these 3 and show you that we can do length, and just do a copy and paste. And I'll just change these. So x position 2 minus x position 1 is going to be the length. And we'll just run this. And this looks like I did it properly. And we'll just have a double check that the lengths, those look like reasonable values. So at this point, we've gone to the label indications. It's got a big, broad, call it under-organized table, and now we've sort of started to pick the pieces we want out of it and to work with those, and we can use equations to change them. So now that you can think of ourselves now that the data, because the data, these values are our actual data. If you drag them out, they kind of look like, well, look like not very much, but those would be, let's see what our columns are. So column 8 is X position. Column Z position might be an interesting one because it should be roughly incrementing. So anyway, they're not very useful to look at as data, but they are data is probably my point. Okay, so let's start working with the indications data. I sometimes call it the feature data. And the nodes that work with this are things that usually have indications data in it. You know, group indication would be, you could give it a condition, say you match in Z, and that would say, and then it would give you a different subset up for clusters along the scan axis. Merge indications would take indications together that were overlapping and take the min and the max of various properties and give you a summary. Tag indications is a useful one for tagging for training in that it has tools where you can use mouse moves or annotations to fill a column that will say a certain tag in it. So it gives you an input to tags. Those are, but you know, you can explore these. They have various purposes. Let's look at filter indication. And I'm going to drag the filter over here. And so now in this one is a good example because we're going to be looking at the data on the output. So data, and then it's the source output, and we want to look at what's it called? I think it's XY, group XY. So remember when a bunch of indications line up in the same place as XY, we kind of think that's a standing wave. So we'll just do group XY group count is less than, pick a number, 5. Okay, we'll run that. And the first thing we'll see is we've gone from 150 on the row, the second line there, and we've gone to 37. So we've picked 37 indications that look like they're standalone. Okay, so one more tool that's very useful in this case is indications data annotation. And that is going to take values out of this table and use them to populate annotations. And so we need to start by doing set annotation type there, and we're going to have a multi-D box. Okay, run that. Okay, so we look at this property map thing, and this reads as follows. This is the property in the parent node in the table above, and this is the property in the annotation. Now, since we chose multi-D box, it gave us its best guess as to what it might be, but since everything, especially on this side, is user definable, it may be wrong, so you may have to go in and edit it. But I think this one will work, and let's just run it. And this table will tell us it built a bunch of annotations, and it's got start and length, and I think they look reasonable. So then we want to put it on our data, so we do that by making a connection here. And I think we'll need to run it again. And let's just bring the data out. And that doesn't look right yet. So let's track what's going on with that. So first thing we need to know is this annotation here is what we call the prototype. So it's the golden annotation, and all the properties other than the ones we specified from the table are copied from it. So see a couple of things wrong here. Show always means even if you're showing, say, from 10 to 20 in Z, when you're looking at a plane of 100 in Z, it's always going to show that annotation. So we want to show that only when in range. So that's a straightforward one. And then we're not showing on the sweep axis. That's obviously a problem. And then we run, what is it? Reset annotation properties. Okay. So now we're in business, and you can see the ones that it's picked, and you can see also a bunch of standing wave ones that it hasn't picked. Okay, so yeah, anyway, I think that gets us through a simple label indications and labeling the annotations and working in the feature domain example.